All right, so what we're talking about now is we've got a system that is essentially a bridge that collapses down to a very small space, and from that you decided, what if instead of putting foot pads or something for people to stand on, why don't I put solar panels there instead?
Yeah, that's basically right. Just to let you give you an idea, the bridge was 21 feet long. It sat actually on some stairs. A stair stand is, I think, what we refer to them as, but basically a three-step stair system that sat on these platforms on either side of the vehicle, and it spanned that 21 feet across there. And those panels were actually drop-in triangular panels that fit into this truss structure and locked in place. And they worked very well, but they were actually manually installed after this truss structure quickly deployed.
Right.
But the whole thing set up very quickly. But yeah, it went in. And at about that time, the beginning of the end of the program became obvious.
Yeah.
And we had one of these structures built, and NASA decided they didn't want to spend the money to build two more. Actually, I should back up. USA actually built the first one, tested it, the prototypes, built one, and actually gave the final product, I should say, to NASA for use on Atlantis and used it till the end of the program.
Right.
They never built the other two units that were going to go to the other two processing facilities.
Okay.
And so when the end became obvious, I started looking at, we had already, quite frankly, we had done quite a few studies looking at applications of this thing, not only for terrestrial use in the space program, but also for lunar use, that type of thing, on orbit as well, and did some analysis and that kind of thing.
This is somewhat similar, Jim, isn't it, to what we see? I mean, obviously different materials and things, but similar to what we see for how they deployed the solar panels on the International Space Station?
It's similar. They use a truss structure, but theirs is of course, being in zero-G environment, is much less rigid system, but it collapses down even more compactly than ours does. I didn't tell you, but the platform across the 1307 bulkhead access area there had roughly a 10-to-1 compaction ratio. So that 21-foot platform shrunk down to about 2.1 feet roughly.
Yeah. Wow. Okay. So bring everybody kind of up to speed. So you and I got to talking about this actually through Dave.
That's correct.
That what I'm looking at, of course, with Quikbyke and our pod system is a way to stow and deploy solar panels. And of course, my original concept was we just mount a bunch of panels on top of this thing, and and that would be good to go. Of course, that's labor intensive, and so in coming across what you guys were doing, it kind of made sense to explore this thing where I've got all these panels and I can do this with them in series, and I can open the side of the thing up, I can roll these out, and as they roll out, they just do this, and I've got a canopy and the energy to power the pod. So that's kind of where we were going with this idea.
Yeah, that's correct. And I stopped short of telling you, but at the end of the program there, we started looking for the other terrestrial applications with the intent, specifically started looking with ways that we could demonstrate a technology that would not only help Kennedy Space Center, but also would potentially spin off into a company that could employ people that otherwise might be on the street after the end of the program. Right. That was my intent.
Right.
It didn't quite work out that way. But,
never does.
Exactly. But we had looked at that, and I said, well, okay, as you know, in 2004, we were hit by like four hurricanes that year.
Yeah.
3 within about, I think, 2-week period, if I remember correctly. And so it was sensitive. We were sensitive to that issue. And Kennedy Space Center, as you probably would guess, has a ton of generators that they use for emergency management, as well as other just remote operations in places around the Kennedy Space Center.
Right.
So I kind of sold them on the idea of taking the technology that USA had already invested so much time and money in, and then we gave that finished unit, of course, for the access platform, actually turned it over to the program. And said, well, why let it go to waste? Start looking at ways to deploy solar panels. And we'd already looked at, one of the applications we'd looked at when we were studying on orbit applications was not only deploy solar, but deploy space-based radar panels, that type of thing.
Okay.
So you're just deploying panels. It really doesn't care what you're deploying.
Right. Right.
So I said, well, why not do that in a 1G environment, which we already proved we could do it with as a work platform. And quite frankly, the load requirements as a solar array is a lot less than what it was for this access platform.
Right.
So we worked that out, got permission to build one, and behind me, I don't know how well you can see it on the board behind me, you can actually
see it really well. Yeah.
It's about a 5 kilowatt system, and you're seeing about half of that system, I believe.
Right.
We started looking at that, and by the time we actually contacted you, I think Dave did. Dave worked with Rocketdyne, but has been helping me do business development and business management on trying to help my business survive.
Right.
And started looking at electric bicycles and came across you and found that you were interested in this idea of the Quikbyke kiosk, if that's the right terminology.
That works.
We had already looked, quite frankly, at using shipping containers, 20 and 40-foot shipping containers, for military application. So it was not much of a stretch for us to look at your application. We can put approximately 50 to 60 kilowatts, depending on the size panels, in a 20-foot shipping container and quickly deploy those on site somewhere. In your case, is a little different because the kiosk is full of
bicycles,
other stuff.
Yeah.
So we looked at applications, a way to do that, and we were happy to do that for you.
Yeah, well, that's great. Okay, so do we have time? Could you sort of walk us around and unfold one of those for us? And also, while you're walking around there, not only does this apply to solar, but you've also now, as I understand, developed a similar approach to putting up a wind turbine.
That's correct. We have a vertical version of our truss technology. It happens to be triangular in shape.
Right.
That goes from roughly a 6-foot stack of triangular tubing, triangular shaped tubing structure, deploys up to 105 feet in the air. At least the final version is. What we've built so far is a 42-foot tall prototype.
Okay.
And unfortunately, I can't show it to you deployed today. We've got it in 3 pieces sitting in.
Oh, okay. All right.
We hopefully be able to show that in the future. I don't know if you're going to be able to put our website up for people.
Yeah, I'll have a link to it. Absolutely.
There'll be several things that they can see on the website they won't be able to see today because I just don't have room in my shop to deploy all this.
Right.
Okay.
So where do you see the company going from here? Where would you like to see it go? Let's say 5 years from now.
Oh, wow. Well, I'm not a really good goal setter, that type thing, but from the very beginning, quite frankly, Bill, we felt like that we could create quite a few jobs, and that was the original intent. But as you know, because of the hurricane type sensitivity in the relationship to emergency management, there are a lot of good things you can do with this technology. So I guess whether it ever becomes a Forbes 500 type company or not, there are a lot of folks that can be helped in hurricane areas or other disaster-related areas that we feel like it has great application for. The military has already shown that some interest in our technology, and some of our panels are being tested right now, actually. But quite frankly, David and I both have a heart, and I'm sure you do too, heart for ministries in various parts of the world, third world countries, and even areas inside our own country, where this technology, especially in places where you don't have a grid, can really change people's lives. And we'd love to see, whatever size the company ever gets, we'd love to see our hardware used for those types of things.
Yeah. So just for an example, so people have a sense of the time. Typically, when someone puts in a solar system, they've got to build the rack system, and then you mount each one of the individual panels, and you snap them all together, and then that connects into the inverter. Very labor intensive.
Yes.
But then designed, of course, to be there for the next 20, 25 years.
Right.
What we're talking about here is an application where you're not looking for necessarily long-term deployment, but you would love to be able to have one person or two people simply take and unpack one of these things, and it just, like an accordion, all folds out. And how long would that take, that unit behind you, the 5 kW unit, how long would it take to deploy that?
That one had 4 wings, and each wing was about 20 feet, 21 feet long, I think. It was 7 panels in each wing. And it took about 10 to 15 minutes per wing, so probably close to an hour.
To an hour to set up
Yeah.
5 kilowatts.
Right. Right. Now, but we've done much better since then. That
Yeah.
was, again, that was a system to design to Kennedy Space Center ground support equipment requirements, which are
Right.
very stringent, very heavy, and you're going to be able to handle a lot higher winds than you might have to handle in an environment after disasters happen.
Right.
And we've not only that, but we've improved the time to deploy, so we can design a system that can very quickly be secured if you have a situation where, and that one was pretty quick to fold up as well. I don't mean to put it down, but it was the first of its kind, and we since have really made it operationally easier to deploy.
Right, and also the compaction ratio, you were telling me you
That's
really
correct.
improved that significantly.
Right, we went from 10 to 1 to 14 to 1 to 17 to 1, and now to roughly 22 to 1 in the past 4 years, basically. And yeah, two guys can deploy 3 kilowatt system that we got, roughly a 3 kilowatt system that you'll see on the video, in less than 2 minutes. Just a round number we're using, 2 guys can deploy a kilowatt a minute. Okay?
Yeah, yeah.
So it's pretty impressive. So it's an entire 20-foot shipping container, in theory, could be deployed by 2 guys in an hour.
In an hour, and that would be how many how many kilowatts?
60,000 watts or 60 kilowatts, 50
kilowatts.
to 60.
Yeah, 50 to 60 kilowatts. Amazing. All right. Well, look, we're going to keep this dialogue open. At some point, obviously, I want to find a way to pay you guys to help me do this.
Right.
But you know what that's like.
Exactly. Now we want to help you, but certainly we're looking to turn a profit here.
Absolutely, absolutely. So yeah, talk is cheap,
right.
but talk doesn't always get the hardware out in the field. So
yeah, as you can imagine, we get quite a bit of interest in the product, and that's
right.
the interest is not the trouble.
Yeah.
Yeah.
All right.
Yeah, we're looking as you would imagine. Often when I mention off grid, the first thing that comes to mind is very remote areas in third world countries. But there's some areas that are very nice that people love to go on vacation to,
right.
called islands, the Bahamas and Bermuda and places like that. We're looking at all those places as potential selling points for
exactly, and that's where I want the Q pod to be that demonstration of that technology. So we'll find a way to make this happen.
Absolutely. We look forward to working with you to do that.
Great. Thanks a lot, Jim. I appreciate it. Dave, thank you, sir, lurking back there somewhere.
They can come on camera and wave, right?
Okay. All right. We'll see you guys later.
Okay. Do you want to show any of the hardware later?
We'll send everybody over to the website.
All right. Sounds great.
Okay.
Thank you, Bill.
All right. Talk to you later.
Have a good day.
All right. Bye-bye.
Bye.